Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with some functions questions, and with that in mind, let's dive straight in. They've said to us, given f of x equals minus 3 over x plus 2 plus 1, and g of x equals 2 to the minus x minus 4, determine the equation of the axis of symmetry of f which has a negative gradient. Leave your answer in the form of y equals mx plus c. Now this is a question that always gets sneakily put into your maths exams and tests, and it's a useful 2 marks if you know how to do it. Right, so let's have a look at what they mean by an axis of symmetry. So the starting point is to look at what type of curve f of x is. Now we can see it's clearly a hyperbola, the reason being we've got an x in our denominator. So if we look at a typical hyperbola, we've got something that looks like this. And when we look at axes of symmetry, we have two. We have the one that slopes upwards, and when we have the one that slopes downwards, okay? Now, the typical axis of symmetry is going to be y equals x or y equals minus x. But that is assuming that our curve hasn't been shifted up or down or left or right. And we can clearly see in this case that there has been a shift because we've got an asymptote that's going to be on the x side, and we've got an asymptote that's going to come in on the y side as well. And what that does is it shifts our axes of symmetry up or down or left or right. Okay, so that's very important to remember. Now they've specifically asked us for the axis of symmetry with the negative gradient. So let's find that. Okay, so let's find the negative gradient. So the negative gradient here, we're looking at y equals negative x. So we're going to start off with y is equal to negative x. And remember, we've got plus c. So the m here is going to be our negative 1, and that doesn't change. Okay, that one doesn't change. Now we need to try and solve for c, and we've got a y and an x in the way, so that's tricky to try and deal with because we've got 3 unknowns and not enough information. But what I want you to remember is your axes of symmetry, there's always going to be a single point that falls on them. And that single point is actually the point at which the two asymptotes cut each other. So if you can see on this curve, for example, we've got the point that they're cutting each other is going to be at that point 0 on the traditional curve, because that's where our two asymptotes are cutting each other. So in this case, we can see that we've got two asymptotes that are shifting, and therefore we need to try and find the new point where the two asymptotes connect. Right, so let's find our asymptotes. So asymptotes. Okay. So what are our asymptotes here? We've got x plus 2, and we always know that's always sneakily the other way around. So the one is going to be x is equal to negative 2. And the other one is going to be y is equal to 1, okay, which we pick up from there. That means the point at which both of these intersect is going to be the point negative 2 and 1. Now we can subs that point in to y equals minus x plus c. So we're going to subs that in. So that's going to be 1 equals minus x. The x I need to replace with a minus 2 plus c. That is going to give me 1 equals 2 plus c. And that is going to give me a negative 1 equals c. So that means my axis of symmetry in this case is going to be y is equal to minus x minus 1. And that will give us the axis of symmetry for this particular question. Really good job. Remember, it's all about remembering that the asymptotes is a line on the axis of symmetry, and also to start off with a point, either it's going to be y equals x or y equals minus x, and then your job is to try and figure out what the c value is by subsing in the asymptote point that you have found by finding the intersection between the two asymptotes. So a lot of work for the 2 marks, but very useful to get those 2 marks. And something that, supports your understanding of hyperbolas in general. Very special thank you to our sponsor for making this video possible. Remember to check out our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.